Hey, Terry Caliendo, Dedicated Managers, back again for another installment of the IETF RFC 6749, which is the OAuth 2.0 framework right there. Last we talked about a while ago, I've been on hiatus for a while, having a new baby born and not getting any sleep for a month and a half. Now I'm back trying to wake up, I guess, and get some videos out. Last we talked was the section 1.5 refresh token. And here's the spec here. We're going to skip down. I'll blow this up a little bit. And that was the refresh token right here. We're going to skip the TLS, HTTP. These things are not a big deal. And we're going to go down to 2 here, which is where we are. We're going to talk about client types. So client types are a big deal. There's 2 types of clients. There's a confidential and there's the public. And the confidential has the ability of maintaining the confidentiality of their credentials. So you can store credentials in the code and it can be maintained somewhere. So this would be more for an application that's on a server that you have complete control of, and the client or the user of the client does not have any access to. So if this was a traditional PHP application where Apache or Fast CGI is running the code on the back end before displaying it to the user, that is the confidential type. The password can be stored on the server, secure details can be stored on the server, and the end users have no ability to get that information. And that's as opposed to the public type. The public type is where you're downloading the code somewhere to the user. Now, even if the code is in binary by the time it gets to the user, it's still reverse engineerable. And you can watch lots of videos on security cameras of guys reverse engineering security cameras where they hard code a backdoor password into security cameras, and hackers can get right into your system. That's a whole nother thing to look up, but basically, just because something's in code doesn't mean it's not reverse engineerable. If you give that code to somebody, they can figure it out. So we consider anything where the code is sent to the code that has the credentials in it is sent to the client, then that's not going to be a secure thing, and that's going to be considered public. So installed native applications, which would be like a iOS application on an iPhone or an Android application on an Android phone. Those are, people don't get to see the code the way they'd see the code in a JavaScript application. It's converted to binary, before it's sent, but it's still reverse engineerable, and they can pull passwords out of that. So because that password has been sent to the, the user in some way that's not encrypted, code is not encrypted, they can pull something out. So an iOS app or a Android app is going to be considered by these standards a public client. And then you've got the web browser-based application, which is going to be your React, your Vue, VueJS, ReactJS, those types of front-end applications that are JavaScript applications where you're actually downloading the application into the client's browser. Those are going to be considered insecure because they're hackable. Somebody can look at the code and reverse engineer it in some way. JavaScript being easier to hack or to look at what's going on, because you can just right-click and choose inspect, and go to the application here, and look at stuff that's happening in session storage. There's nothing stored for this site, but you can look at cookies, and I guess there's no cookies stored on this site. But all that stuff is available to a user, an end user or a hacker. So client types, we're defining whether or not they're confidential or public here. Now, just to bring this home, what we're talking about here with confidential and public is when we get deeper into these diagrams here, I'm looking at the authorization code grant that we'll talk about later, but this is kind of showing you some of the pieces and some of the communications that are going back and forth. And remember, the resource owner is the user. That's the person that's typing the keys and entering passwords. The user agent would either be the iPhone or the web browser, and the client would be the code, the application that's running. So this is what we're talking about here. This is either the code that's running, the application that's running on an iOS app or a Android app or the VueJS or ReactJS type of JavaScript code that's running on the front end. So we're talking about this piece right here when we're talking about the confidential and the public. So we'll get more into that. I'll hopefully hit that again when I get into this other one. So then we just want to look down here a little further at the what the IETF defines. So I did kind of talk about this before, but I'll go over it again here. So the specification is designed around the following client profile. So a web application profile. So a web application is a confidential client running on a web server. So again, that's like a backend PHP type action where, you know, Apache is, or PHP through Apache is rendering the page, sending it to the client, and then the client renders it. But the actual application that's making the calls over to Auth 0 or that's doing anything that has the credentials that are secret, they can be kept secret because the actual code that's being run there before it's being turned into HTML or whatever it's being turned into and sent to the user, the front end, you know, those secrets are not going along with the code in any shape or form. So here's that right here. The client credentials as well as any access token issued to the client are stored on the web server and are not exposed or accessible to the resource owner. So here's the resource owner, the person that could be a hacker or is probably using the application, but we're worried about hackers. So, you know, that's different from the client. The client is, again, the code running, and the user agent is the thing that's running the code. So this is a browser for a JavaScript, and this is, you know, the JavaScript code application in a, you know, a VueJS or a ReactJS application. In that situation, if this was a PHP program, the client here, this thing is PHP running on a server, so it's going to get all the authentication stuff and be able to handle it before it sends the web page that it renders back to the user agent, which is the browser, which gets displayed for the resource owner. And then there's user agent based applications. So this is where we're starting to get into you know, JavaScript front end applications, which would be React or VueJS again. So again, in my sleep deprivation, I'm not exactly sure if I did say this and what I said before. I think I described the PHP, but now if in this situation we're talking about like a VueJS application, where the user agent based application is a public client in which the client code is downloaded from a web browser server and executes within the user agent. So this is the user agent, this is the web browser, and it's downloading the VueJS code or the ReactJS code. It then runs the code as the client. That code is considered the client, the application code, and so that code is what's making the calls, you know, back to the authorization server and doing whatnot. That client is residing in the web browser. That code is there to be reverse engineered. It's being sent to the, you know, this exposure point here, the resource owner. So it can't have client, you know, can't have secrets in it that that would allow somebody to, you know, access your entire application. So that is considered, you know, that's a user agent based application. And again, really, it says up here that you know, the client type designation is based on the authorization server's definition of secure authentication. So this guy gets to decide which is actually which type, but for the most part, the web application is considered confidential, the confidential type, and the user agent JavaScript, where it's downloaded to the browser, is considered a public client type. And same thing for the native application. A native application is you know, code that's downloaded onto like an iPhone or an Android, and it's still accessible by the, you know, the resource owner or the end user. So it also cannot contain any secrets, even if they are in, you know, binary form. They can be extracted, and that's what this paragraph talks about. So in that case, if we look back at this diagram, this user agent here is no longer a web browser now. In this case, it is the device, the iOS device or the Android device, and the client is the code, the application that's downloaded to that device. That code is still, again, can be reversed. It's sent to the client. The code is not residing on a server somewhere. The code is not on the client somewhere. In a server situation, but in this situation, if we're talking about a native application, an application on an iOS or Android device, that code is on the device and can be extracted and can be reverse engineered. So it is again typically considered not necessarily is considered a public type. So that's those are the three major types that are using this protocol. And in the next video, we'll start to get into I might go into the client identifier and the client authentication. Ultimately, I'm looking to get to, this is where the brass nuts are right there. The obtaining authorization, the code versus the implicit or password. Those are the three types that you'll use in most situations. So again, Terry Caliendo, dedicated managers. That's us right there. If you're glancing over this stuff and you're having problems with it, you need some help, feel free to give us a call. Hit the contact button there if you've got a project that you need help with or just need to outsource, give us a call. Dedicated managers on YouTube. Here we are, youtube.com/dedicatedmanagers. Please hit that subscribe button, follow for more videos, and we'll see you in the next video. Thanks a lot. Take care. Have a great day.